Greetings everyone, and welcome to week 10, in which we'll be looking at Galileo, the Medici patronage of early science, and challenges in the exploration of the known and unknown universe more generally. Part of our goal for this week and the next is to understand how Florence and Tuscans and the Medici contributed to what historians, since Alexander Claret first came up with the term in 1939, have traditionally called the scientific revolution. We'll discuss first what is meant by that and how historians approach to studying 17th century developments in scientific thought and experiment have changed over the course of the last 100 years. Then we'll turn to Tuscany in particular and understand how the patronage of wealthy and powerful individuals, which had long been the force for shaping culture and learning in Italy, also became key to the development of modern science as we now know it. Galileo and his relationship with the Medici is the focus here, which goes the same for your secondary and primary source readings for this week. First, we might think of what is or what has been meant by the scientific revolution and how it has been treated by historians. So when I say scientific revolution, what comes to mind? For many people, it is Galileo and telescopes, or Newton and an apple. For others, they think of a religious versus secular divide. The scientific revolution was a movement or a period in which we all learned that the earth wasn't flat, that it wasn't at the center of the universe, that astrology could not tell us our fates, and that the church was not the only and irrefutable source of wisdom in this world. In fact, for many, the scientific revolution still signifies a period in which we broke away from the stranglehold of the Catholic Church into the dawn of a new enlightened age of scientific method and a rational and perhaps even atheistic understanding of the world. Well, where do these impressions come from? Much of it stems from the way that science, or as contemporaries would have understood it, natural philosophy, has been talked about by historians in the last century, beginning with Alexander Claret in 1939, who first coined the phrase scientific revolution. Historians began to see new ideas about our universe that emerged during this period as forming a coherent new way of looking at the world. They saw Copernicus's heliocentrism, Galileo's moons of Jupiter, Kepler's elliptical orbits of the planets, and Newton's theories about gravity and light as all part of a larger revolution, understood in the sense of an all-encompassing major change rather than a cycle that would fundamentally open the minds of Western Christianity. We went from dark, from superstitious religious nonsense, into the light of pure scientific reason. Well, in the past decades, historians have shifted from focusing more on the characters themselves who practice natural philosophy, or shifted to focusing more on the characters themselves who practiced natural philosophy and the places in which they worked and conducted experiments, rather than simply on the major ideas and inventions that took place almost as if in a vacuum during this period. Even more recently, the focus has shifted to complex networks that natural philosophers maintained with one another, and the transmission of scientific knowledge across vast distances over greater periods of time. Although natural philosophers were certainly aware of the advances of their contemporaries and eagerly sought out opportunities to capitalize on existing knowledge, it seems highly unlikely that staunch Anglicans like John Evelyn or closet Arians like Newton or even devout Catholics like Descartes were aware that they were forging the path to scientific enlightenment and a secular world, and they very likely would have been distressed if they were so informed. With new focus on the activities of these men, the environments in which they worked, and the people they interacted with, we have a clearer idea of how natural philosophy was not only practiced in early modernity, but also of the belief systems of the practitioners themselves. So, probably Galileo would have looked at you as if you were out of your mind if you suggested that his theories and research should be seen as contradicting the existence of God, that they were proof of the superiority of a secular understanding of the world. Although some historians, previous historians, have argued that his theories, among others, marked the definitive shift towards a modern secular understanding of the world. So let's take a closer look at what was going on in the late 16th and early 17th centuries, both in Italy and really right across the Old World, from Persia to England, to understand some of the ideas, people, and institutions that created, if not a revolution, then the coming of new ways of understanding our universe. First, let's think about the way people really understood their universe and their place in it during this period. So anywhere from the late Middle Ages right up through the mid-17th century, and how knowledge of the natural and supernatural world was produced and disseminated. So since the Middle Ages, universities had been centers of learning and monasteries repositories of information where monks labored away in the scriptoria, the libraries inside monasteries, to produce books by hand. As we've already seen, the invention of the printing press and the wide-scale distribution of printed works would have a transformative effect upon European societies. It is really important to recall that universities started out as guild corporations, the oldest being the University of Bologna in 1088, which was established to promote the study of Roman law, but they were also religious institutions. And to enroll men, was really always men, women not being permitted to officially enroll at such institutions. These men had to take what were known as minor orders, that is, basic religious vows that situated them within the lowest level of the church hierarchy. Although if you so chose, you could go from taking those minor orders on to taking major orders, which would then lead you into the path to the priesthood or another branch of the Catholic Church. University, the term itself, comes from universitas, meaning the whole or everything. So the full phrase being universitas magistrorum et scholarium. And it was here that young men learned the trivium, which was grammar, rhetoric, and dialectics, or logic, and the quadrivium, which would have been arithmetic, geometry, music, and astronomy. The method of teaching from which they learned was part of what we would now call scholasticism. It emphasized the Socratic method of disputation, of questioning and answering, and also emphasized deduction rather than induction. So what's the difference? Well, a very simplified answer is that deductive reasoning, starts out with a maxim, a truth, and then a series of logical steps are taken to prove that maxim. Inductive reasoning, on the other hand, features on a different, more ground-up approach, in which the student accumulates lists of data about a given question and supplies an answer to that question, which is, in all probability, true, but is not beyond questioning itself. The result is not beyond reproach. So this is the foundation of the Baconian method and the scientific method as we understand it today, and I'll talk a little more about that in a moment. But we should also take a moment to think about where much of this knowledge comes from. Modern science would have been impossible without the contributions of Muslim scholars. From the 8th century onwards, as we have already seen, Muslim scholars from Isfahan to Cordoba were having a renaissance of their own, finding and translating Greek texts and using the geometry, mathematics, and philosophy of the ancients to revolutionize their own societies. And they had their own centers of learning, colleges, aristocratic courts, and an extensive array of schools, madrasas, where young men were instructed not only in religion, but also in philosophy, astronomy, mathematics, and geometry, among other topics of learning. So, while the practical considerations of ruling a vast empire, um, such as the need for, let's say, the building of canals, would require the utilization of the more advanced Greek uh, geometry and mathematics. While this was always an element of this translation movement, um, scientific activities themselves among Muslims continued long after these initial real-world benefits were realized. Mathematician astronomers, or muwaqit as they were known, were from the 13th century onwards employed by mosques to determine accurate times for daily prayer. Madrasa and mosque libraries often held extensive collections of works that could be grouped under the sciences heading, and translation of these documents were often carried out under the aegis of these institutions. So in recent years, scholars of the history of science have finally been recognizing the key contributions of Muslim scholars to the development of modern science. It is true, however, that some other scholars who fall into more of a quote-unquote clash of civilizations mindset, that being the idea that Christianity and Islam belong to separate, discrete cultures, and that their history is one of never-ending conflict, a conflict that continues uninterrupted to this day. But aside from these are the scholars that have said otherwise, that have said essentially that because Muslim scholars never embrace the heliocentric view of the universe, the view that the planets revolve around the sun, that this is some proof that Muslim science has never advanced like they did in Western Christianity. This view, of course, has been thoroughly challenged in recent years. And historians are now taking a more globalized approach to the history of science. We have realized that it is not sufficient to study the evolution of new ideas on their own. We also need to study the people, the actors themselves, as well as their environment. So where did these ideas emerge? How were they shaped? By whom? Why? So in short, the historical context, it seems like kind of a no-brainer, but there was an older method of studying the scientific revolution which placed emphasis really just on the ideas themselves. And increasingly now, historians are looking at the ways in which these new ideas were transmitted. So how ideas traveled. This has led to a rise in network analysis to understand how early scientists got in touch with one another, how they remained in touch, and where they exchanged their ideas. This will be examined actually in our next lecture, our lecture for next week. But in the 16th century and into the 17th century, there began a slow but irrepressible challenge to the older kind of method of instruction and learning that one would find in the Western Christian universities, the scholasticism, the focus on deductive reasoning, on Aristotelian physics. This happens for a number of reasons, one of which is the discovery of the New World and the news of new lands across the Atlantic and a new conception of the vastness of the world. You may have heard that pre-modern people thought that the world was flat. This is nonsense. Even before Copernicus postulated his heliocentric system, people knew the world was a sphere that was observable. The simplest sailor out at sea could tell you that the world was round, based on the curvature that he would see of the horizon from the ship. But additionally, the world had always been taught, it had always been taught that the world was round, because that was the most perfect form in the universe. And God's universe was a glittering universe of perfect spheres with the earth at its center. So even the ancient Greeks had higher education, again, in pre-early modern Europe, was based upon an Aristotelian view of the universe and Aristotelian physics. So Aristotle and Ptolemy after him argued that the earth was at the center of a universe of perfectly round spheres, and that the earth was moreover the most perfect of them all. Aristotle's physics were goal-oriented, meaning that all objects created, in creation, wanted to arrive at their natural place. So what does this mean? Well, it means that if a piece of metal is dropped from your hand, we ask, why does it fall down instead of up? Well, Aristotle would say because metal is heavy. It's a base material, just like the center of the earth. So heavy materials fall down because they wish to arrive at their natural place, downward. So then we could also ask, well, why does the flame of a fire leap upwards? Well, because the flames aspire to arrive at their natural place, which is beyond the earth, in the ether and the crystalline spheres which house the planets. Centuries of Christian scholars, much like St. Thomas Aquinas, as you'll remember from St. Thomas Aquinas, as you'll remember from previous weeks, sought to harmonize Greek teachings with Christian ones, and they found ingenious ways using deductive reasoning to make everything match up. They really had to, you see, because you can't have competing views of the universe, competing systems of knowledge. You had to prove that Christian theology was not only compatible with Greek teachings, but the logical summa, the logical culmination of thousands of years of human knowledge combined. The Bible said that the sun moved across the sky. Greek scholars had worked out a system which said the same. Bingo, perfect match. The only thing that seemed a bit odd was when the planets went into retrograde. So that is, at a certain point in the year when they appeared to move backwards. Now, this is rather problematic if you're supposed to have all the planets circling around Earth in neat revolutions. But wait, said Ptolemy, they're not just moving around the Earth, but moving in neat little circles of their own at the same time, which he called epicycles. Now, these are not spinning on their axis, but they're actually spinning like little miniature rotations, little cycles within cycles. This would explain the retrograde motion. Another factor in the 16th and 17th century revolutions in natural philosophy was the rise of humanist teaching in academies and universities, where scholars trained in Greek and Latin resurrected the old works of the Greeks on mathematics, geometry, and philosophy. So again, in this, they also owed a great debt to the Muslim scholars, for if they had not rediscovered and translated many of the old texts, they may have been lost forever. Access to more accurate mathematics and geometry meant that the tools for measuring the heavens, such as the sextant, were made more accurate as well, and then that the computations required to measure the revolutions of the heavens also became more regularized. And so essentially, this Ptolemaic system, again, that you see, that was taught and promoted across Europe and accepted across Western Christendom, remained in place really until a troublesome Polish priest comes along to tear the whole thing apart. Now, that's certainly not what Copernicus intended to do. As a matter of fact, he was really just trying to point out a few problems with the church's calendar. Again, Copernicus, a churchman himself, but educated in the humanist sciences at several universities, including the University of Bologna, had worked out, using his humanist training, that something was really off with Ptolemy's view of the universe and with the solar calendar. Now, it's not news necessarily to the church. The calendar that the Europeans were working from, the Julian calendar, they knew that it didn't quite correctly match up with the heavens. So the Julian calendar had 365 days, and it divided into 12 months, and a leap year was added to February every 4 years. So the Julian calendar was on average like 365.25 days long, and it's intended to be a sort of approximate solar year. Though the problem was that it doesn't actually it didn't actually compensate for the shorter the fact that the tropical period was actually a few minutes shorter than what the Julian calendar had calculated. So essentially what happens is that the Julian calendar, gained approximately 3 days every 4 centuries. So the Gregorian reform of 1582, which is named after Pope Gregory VII, fixed this issue, which results in the new Gregorian calendar. But in the meanwhile, Copernicus had stimulated by the fact that he's trying to work out why the calendar doesn't exactly report the solar year accurately. He continues to work on his masterpiece, which is the De Revolutionibus Orbium Coelestium, which is on the revolutions of celestial bodies. And in this, he sets out his heliocentric theory. It was published in 1543, the same year, I believe, of his death, though the bulk of the work had been completed a decade before. Copernicus held off publishing it because he was terrified of being the laughingstock of Christendom. Everyone knew, they really knew, that the Earth was the center of the universe. Christian doctrine not only said so, but it was also common sense. Moreover, Copernicus' idea that the Earth was rotating on its axis, that we have a 24 cycle of day and night depending on the Earth's exposure to the sun, seemed equally ludicrous. God had fixed the heavens in their places. And besides, if the Earth was spinning around, wouldn't we all go shooting off into the cosmos? Still, his work made a splash, and other natural philosophers who were working on similar ideas took up his writings and folded them into their own studies and teachings. Still, this new science, for it really was very new. Scholars like Galileo and later Newton and others would come to see themselves as the moderns, as the standard bearers of the new natural philosophy, which they saw as superior and more dynamic to that of the Greeks, the ancients. This new science, however, was really becoming a serious point of worry for the church. So let's recall briefly that the church had just done a major overhaul of its infrastructure with the Council of Trent and was really bent on homogenizing all of its practices and positions. The church had been reformed, the Inquisition was in full swing, rooting out heresy, and the Jews had been confined to ghettos. All of this was part of the church's larger plan to regularize the world under codified Christian teaching and to extend the reach of Christianity. Again, as we remember from last week, the church was also at that very moment attempting, either by force or by persuasion, to gain new converts among the indigenous populations of Africa and the New World, and to bring Christians of the Eastern Mediterranean back into the Catholic fold, the Western Church's fold. They did not like the idea of fracturing the science that had for so long held together Greek and Christian knowledge. So let's take poor Giordano Bruno, for example.